Hi, I am Alas Rasim, a civil engineer with over 40 years experience in the field. I've worked on everything from on-site execution to detailed structural design work on the computer. These days, I focus on automating structural calculations and sharing my knowledge with others who are passionate about structural engineering and analysis. If you are into practical tips, engineering insights, and automation in structural design, you are in the right place. In this video, I will show you how to automate structural calculations using Excel spreadsheets by creating your own calculator for simply supported beams with uniform distributed load. You will learn how to use spreadsheets like Excel to perform basic structural design and calculation tasks. Whether you are a student, engineer, or just curious, this is a practical guide you can apply right away. Section 1. What you will learn. We will walk you through setting up a calculation sheet, inputting loads and section data, automating formulas for bending moment and shear force, and checking design limits using Eurocode formulas. Section 2. Why use spreadsheet for design? Spreadsheets offer speed, flexibility, and repeatability. Instead of doing every step by hand, you can build smart templates that adapt to new inputs. That means fewer errors and faster results, especially for common elements like beams, columns, and slabs. Section 3. Example. Beam design step by step. Let's design a simply supported beam HE300A with a uniform distributed load W. Step 1. Define inputs. In column A, we list our inputs: span length, load per meter, material strength, section modulus, and web area. In column B, we enter values: span length in meter, load kilonewton per meter, material strength newton per square millimeter, and web area in square millimeter. Step 2. Calculate reactions and internal forces. We use simple formulas for maximum bending moment, M equals WL square over 8, and for shear force, V equals WL over 2. Excel handles these basic cell formulas like B3 times B2 squared over 8 and B3 times B2 over 2. B3 times B2 squared over 8 and B3 times B2 over 2. Step 3. Check section capacity. Now we compare the applied moment with the section moment resistance. We can add logic if applied moment less than moment resistance, then it is safe, otherwise it is unsafe. This gives us instant feedback on whether beam is safe. Calculate moment sections resistance MR equals section modulus times material strength, and shear sections resistance VR equals web area times material strength over square root 3. In this part, I will walk you through the cell references using arrows so you can easily see how Excel handles the equations with basic cell formulas like sin equal B3 times B2 square over 8 and how the applied moment and shear force update when the input values change. Section 4. Final tips. To make your sheet reusable, use cell names or colors for input. Protect formulas from being overwritten. Add unit labels. Add conditional formatting for pass-fail check. That is it for this basic example. You now have a template for designing beams using Excel. In future videos, we'll cover columns, slabs, and even wind loads. If you found this useful, like and subscribe to follow the full series. Thanks for your interest and your time.